Artists are innovators almost by their natures, and they've long explored the potential of technology, whatever that's meant in their particular era. Now that it includes such things as automation and artificial intelligence, does it raise the risk of displacing creative human minds altogether? Or are algorithms and machine learning just additional tools for artists to evolve their creativity? Let's find out. Joining us now in Kelowna, British Columbia via Skype, Leanne Gabora. She is a cognitive scientist at the University of British Columbia's Okanagan campus. And here in studio, Adam Hammond, author, literature in the digital age, and a professor of English at the University of Toronto. Catherine Moore, adjunct professor of music, technology, and digital media, also at the U of T. And David Rokeby, a Toronto-based artist who's been using a form of automation and AI in his exhibits since the 1980s. Delighted to have you three here in studio. Leanne, so nice to have you on the left coast with us this morning, or I should say this evening. Let us start with you, Leanne. Your area of expertise is called computational creativity. And I guess we need to start by understanding what exactly that is.
Computational creativity could be defined as effort to make computers do things that are new and innovative, I suppose.
And how did human brain processing change over time to allow us to become more creative?
That's exactly something that I've been working on for the last 2 decades almost. So see, you can ask the question, why is it that we alone have just completely transformed the world that we live in? So anatomically, our brains aren't so different from those of other species, but what we've done and what we've been able to do is really, really different. You can say that our other species do things that could be called creative. So they can invent new tools actually and do things that they haven't been done before. And they can also imitate each other. So what actually makes humans unique is the fact that we can build on each other's innovations. We can put our own spin on things that other people have done. So we can adapt them to our own needs, our own tastes, our own desires. And that would be specifically human.
Well, let's go to the next step if we can. How do you apply the evolution of human creativity to try to make computers more creative?
Well, one thing that I've been trying to do is to understand through computational modeling if we can get computers to be creative in the ways that humans have been by changing how their underlying mechanisms work. So I've been using an agent-based model, which is basically a little society composed of individuals. Each individual has something called a neural network. And each agent can do 2 things. They can invent a new idea or they can imitate their neighbors. And through this combination of inventing and imitating, you get progressive cumulative change in ideas over time. And so there was a big change in human creativity about 2 million years ago. That's when you see not exactly the onset of tool use, but the onset of tools that require different stages. And you see a bunch of things going on in the archaeological record to indicate that there were home bases, that people were sort of using the same places for periods of time, and that they were able to cumulatively add on to each other's innovations. And so I got this agent-based model to implement something called chaining, which basically just allows them to take one idea and add onto it another idea and add onto it another idea so that they could turn simple ideas into complex multi-part ideas. And when I did that, I got the same kind of cumulative change over time that you see in this period in the archaeological record.
All right, let's follow up on that and go to David, because we mentioned in the intro, you're into your 3rd decade of incorporating technology with your art. Where'd you get the notion to do that in the first place?
The computer posed an interesting challenge in the early 80s. And one of the things that it did was it made me question what it meant to be human. Strangely, it reflected me back on myself. I started questioning what it means to have a body, because the computer doesn't. The computer makes me want to forget I have a body. It made me wonder what intelligence is, because the computer was starting to do things that were maybe sort of intelligent, but I thought it needed to be asked the question need to be asked more in depth, shall we say.
We've got a short clip here of one of your works. Is it called Sorting Demon?
Sorting Demon.
Sorting Demon. All right, let's roll the clip and you can set up for us what we're about to see. Sheldon, if you would, let's roll this right now.
So the Sorting Demon is a piece that looks at intelligence, shall we say, automated intelligence and surveillance. So it's a piece that looks out onto the street, this is on King Street, looks for people. When it finds people, it captures them, it separates them from the background, and then it sorts them according to color, size of head, and somewhat controversially by skin color, things like that. This was around the time of the First Gulf War, when there was a lot of discussion about automatically tracking terrorists, shall we say. So I was trying to ask questions about what it meant to have machines start to judge us as human beings and how we felt about that.
And here is what you had to say about that work 15 years ago. You said, the piece was triggered by my concerns about the increasing use of automated systems for profiling people as part of the war on terrorism, and is an attempt to help ask questions about appropriate uses of technology. 15 years later, how worried are you about all of the algorithms that surround us in so many ways, really intersecting with our lives in so many incredibly different ways?
Well, when I'm in a pessimistic state of mind, I like to call it algorithmic pollution, that we are filling our environment with algorithms that are judging and making decisions that we don't necessarily have a way of critiquing or discussing. And on an optimistic side, there are some wonderful things that it makes possible. So after all of these years, I started in very much a techno-utopian state. This is going to be incredible. These changes are going to be fantastic. I went through a pessimistic state in the 90s when I was really concerned by some of the things I saw happening in my own installations. And then I think, as we got into the 90s and the 2000s, I started to see that, the best position for me to be was really balanced between those two. To be able to critique the system from inside, because I know how to program, I know how to build computers, but to look also from the outside, from a humanist perspective, from the perspective of an artist, from all those things. And so being in that middle space is, for me, the most productive space now.
Gotcha.
To explore, to wonder.
Adam, let's talk about literature for you, because you're helping to transform the landscape of literature with an algorithm that you co-created, I gather, to help a writer generate a story. Explain.
That's right. So a writer named Stephen Marsh came to me and to Julian Brooke, a computer scientist that I work with, a computational linguist, and he said, if I give you 50 of the best science fiction stories that I've ever read, can you derive a set of rules that I can follow to create the perfect science fiction story? I knew right away that we could not do the exact thing that he asked me to do. As I'm sure my panelists will agree, the more you know about this stuff, the more realistic a sense you have of what is possible. But since as an English professor, our job really isn't to solve problems, it's to raise interesting questions. Or in this case, I wanted to just defamiliarize or disrupt, to use Silicon Valley language, the composition process. And also, I knew Stephen Marsh primarily. I read some of his fiction, but I also knew him as someone who had attacked the notion that literature could ever be turned into data. So I thought, this is a great project. Let's see if we can get this very skeptical person working on a project and come up with some interesting rules.
And?
So what we used was we used a series of algorithms, a series of approaches that have been used to study literature, but I don't think have ever been used to create rules for writing fiction. So we use something called topic modeling. Basically, computers are really good at doing certain things that humans are not good at doing. I think humans are great at coming up with stories. So I did not want to use the computer to write a story. It's not the kind of task that seems like it needs to be automated. But there are some things that computers can do amazingly well, like do mathematics, and in the case of topic modeling, see what words tend to occur together in lots and lots of stories. So we looked at thousands of novels, science fiction, non-science fiction, and we saw what are the clusters of words that tended to occur in his perfect stories. And out of those clusters of words, known colloquially as topics, we came up with thematic rules. Things like include a storm in your story, include a scene set on a farm. Another rule was it needs to be set in space, indeed on a foreign planet. So it had to be on Earth and on a foreign planet. Now, these kinds of, the computer doesn't know how the world works, so our process doesn't understand that there are no Earth farms on a planet that is not Earth. But that's why it's fun. It creates a set of challenges for Stephen.
Let's bring this image up if we can now, Sheldon. This was, is this the result of some of what you created here?
Yeah, the story that Stephen wrote was indeed published in Wired magazine, which is very exciting because I don't think Wired publishes fiction. So they published this because, and this is the part that's interesting to me. I think they thought it was written by a robot. I mean, even though that's not what happened, and we provided footnotes, I think Wired and Wired's readers got excited with the idea that the story was written by a robot. Now, in fact, what happened was we created rules from a computational process, and then we gave Stephen Marsh this very complicated editing apparatus. We created a website where he wrote the story, pressed a button to get feedback. It would say, like, you don't have enough pronouns, you don't have enough adverbs. This is, again, computers are great at this stuff. They can instantly count how many adverbs there are and humans can't. And Stephen, there were 25 of these characteristics. Like, you need to vary your sentence length more.
Well, if I know Stephen well, there was probably plenty of profanity in the script.
I'm sure there was a lot, yes.
Okay, well, let's do a little example here, okay? Here we go, Sheldon. Here's an example of one of those rules in action. The other world, 1,564 light years away, was flowing brightly and glamorously into the machine unobserved while Ed gave what must be his boilerplate orientation speech. Okay, that's an excerpt from Twinkle Twinkle. All right, what do we infer from all that?
Well, first thing we can infer is it's not written by a computer. It was written by Stephen, and it was written to follow the rules. I can't think of which of my thematic rules he's following there, but he's following them. And certainly the stylistic rules, there are the right number of adverbs and adjectives and so forth. But Stephen wrote it, and we did this as a challenge to human creativity. And writers love rules, and artists love constraints. And so what was new and different about this is not that a computer wrote it, but that a computer provided a new set of constraints and a new set of challenges. Now, when this came out, there was a surprise to Stephen and to myself, which is that there was a sidebar where very important people in the American publishing scene, the fiction editor of The New Yorker and the head of Random House, gave their comments on the story. And it said, Wired said, we did not tell these people who or what wrote this story. Now, there is no question of what wrote this story. It was a who, it was not a what. But one of the comments from the head of Random House was that it didn't seem human. Now, to me, this gives away the game. They said that a computer was involved, and I think there's a real tendency in literature that narrative is so prized, and we have this sense it's such a human thing, and when computers get involved, we get very anxious. But I think in this case, when you know what actually happened, you don't need to worry. A human still wrote it, and we used the computer to create a new version, or to spur human creativity.
Well, let's go from literature to music, shall we? You helped start a partnership between the Faculty of Music and Computer Science Innovation Lab with a goal, I gather, of figuring out how musicians can use artificial intelligence to their benefit. So what do singers and composers stand to gain from algorithms in this realm?
So I think there's three things, really. One is from a creative point of view, which AI gives creators superpowers in some ways, because it's a way of automating human interpretation, if you will. Another way is the user experience for the listener to music on, say, streaming, where there's all sorts of algorithms feeding you a very personalized, very individualized, surprising, delighting. That's what we want as a listener. You want to be surprised, you want to be delighted, you want to be shocked, you want to have interest in and so the algorithms with AI are trying to replicate that. Because what's surprising to you might not be surprising to us. And so it's very personalized. And there's a very good business case to be made that gives you happy users. And without happy users, you have no business. And then the third is collecting royalties. Because music use is expanding all over the world, many languages, many different cultures, many different media, and collecting royalties from the use of music is thus much more complex, and AI can assist with that.
And, I mean, music's being stolen all the time, right? So that probably complicates matters even more.
Well, it isn't stolen so much as being used by people to create new things.
Stolen's a bit of a pejorative word there.
It's a pejorative word because in the remix culture in which we live, people love to put images together with new images. An example that we saw from David's work of you're taking something captured on the street in the moment and creating it, categorizing it, putting it into something new. People can do that at home now. They love to do it. They love to put their creativity on show, whether it's on YouTube or by any other means. And music's a part of that.
So tell us how is the music industry, therefore, writ large, using artificial intelligence in its daily work now?
Mostly in managing the data about compositions, because there's two copyrights in music. One is for the recording, one is for the composition. If we all sing the same song, it still has the same composer. There are many instances where there are multiple composers, where you have samples. So it's an enormous, billions and billions of data points now need to be managed in terms of paying royalties. It isn't just someone wrote a song, they perform it, it's one person to pay.
Gotcha. Let's go back to British Columbia here. Leanne, it seems that when it comes to advancing automation and AI in the arts, a lot of the progress happens when two silos sort of come together and collaborate. How important is that step in making machines more creative?
Human collaboration or human-computer collaboration?
The latter, yes.
Well, in the work that I've been doing, it's very important. So one of the projects that I've been working on is with Steve DiPaola at Simon Fraser University. And we've been engaging in various computer human-generated artwork projects. In one of them, it takes Darwinian natural selection type processes and evolves more and more beautiful or effective or fascinating works of art. And humans come in at each step of the way and tell the computer which artwork they prefer. And so they perform the selection aspect of the natural selection algorithm. And in another project that's followed that, it uses deep learning to evolve more and more effective artworks. And that one also, there's humans kind of in the loop. The humans are providing the training set to tell the computer what to learn is about what we find to be an interesting artwork, because computers don't have any preferences and they aren't trained in the world the way that we are. So they don't have any ideas about what makes a nice aesthetic composition. And so in the process of training these computers, we're actually putting our tastes and our preferences into the computer.
David, are you doing that too?
I'm playing around with that right now, actually, because of the rapid movements forward of artificial intelligence in the last few years. It's become absolutely essential for me to get my fingers back in there. And it's certainly, there are remarkable kinds of images that these things can create. I mean, that's one of the interesting challenges for an artist, is that out of the research departments of universities around the world are incredible things coming just out of raw research that are this close to being what I would consider art. And the challenge with the artist is, okay, well, how do I do something with this that isn't just what the research is doing, but that actually brings it to the level of art in the sense that we understand in museums and historically important.
I think we have an example of this here. Here we go. Take a look at the monitor here in the studio. This was done in your field, computer-generated art versus human-made art. What's going on here?
I believe this is a project out of Rutgers University,
yes,
where they had a computer using something called a generative adversarial network.
A which?
Generative adversarial network.
Okay.
It's a GAN, better known as a GAN, which is a system that has two components. One thing that generates random artworks and another thing that judges them and says, no, that's not good enough, go back. And the two fight it out until they start to produce something that it accepts as an artwork. And I should say that it's seen a whole bunch of artworks. The critic part that says, no, that's not good, has seen like a few thousand or tens of thousands of images. So it's saying, no, go back, try again. And eventually you end up with images that seem like real artworks. So then they asked humans to say, well, gee, okay, do you accept these as artworks? And compared to works at Art Basel, one of the biggest art fairs in the world, or versus known pieces of abstract expressionism, do we judge those as real artworks? And apparently most people preferred the computer-generated ones to the ones from Art Basel, for example.
Well, here's the thing. I gather that a survey was done of people who looked at all of these pictures, and half the people couldn't tell what was human-developed and what was computer-developed.
Right.
Is that a problem?
Problem, I don't know. It is kind of beautiful that these systems can produce images that are interesting to humans. One of the real challenges, there are many too many things I could say about this, but one of the key things is when we judge an artwork, when we think this artwork is worth spending tens of thousands of dollars on and putting on exhibition, we're thinking of not just that artwork, that particular painting. Like, I don't know what the Mona Lisa is without Leonardo, his history. Right? So we read into a work of art what we know about the culture it comes from, the artist, et cetera. And whether that's really important or not, it's something we do culturally. And so the difference is an image that may be very compelling that comes from an artwork doesn't come with that whole aura. And I'm not saying that it's necessary to have that aura, but it does move it into a different territory.
But I guess it provokes a lot of questions, one of which is there something, therefore, less about the computer-created work because it doesn't include all of the backstory of Leonardo da Vinci or Rembrandt or Picasso or whomever?
Certainly some people would say yes. Certainly when people are talking about putting hundreds of thousands of dollars out at an auction for a work, they would probably argue yes.
How about you? What do you argue?
I have a much more complicated relationship because I like to make interactive work and I imagine that in fact the work doesn't exist until the person's viewed it. So the person's response to the work is almost as important as anything else that might be involved in the work. And so on a certain level, if a person finds a work inspiring or challenging or interesting, it doesn't really matter how it was produced. And so so I have my own baggage that I bring to this question.
I should hear you on that, Catherine. If music, we've done programs on this in the past here, where music, there's so much formula and it's sort of written by computers, and yes, there's a person at the end of the day singing it, but do we have the same relationship to this art when it doesn't come up the traditional way that it's happened for the last thousands of years?
Well, certainly two of the most successful music genres in the last at least 20 years are hip hop and electronic music. And they use sampling, they use looping, they use beats. The producer is the person that starts. It isn't the lyricist, for instance. So culturally and performance-wise, if you think about electronic music, it used to be someone, usually a man, who was in the dark with turntables or a laptop. You couldn't see them. You were there to dance. Didn't matter. That wasn't a performance by a person. But now, there was an evolution where the person operating the technology, it was a performance. Sometimes there'd be an incorporation of live instruments. You'd have light shows with it. So it's really a blend, and in music, people are very accustomed to this. And across lots and lots of the TSO did a piece last year with dancing. They do a lot of multimedia things too. So, and again, it's the same thing that music doesn't exist without an audience. Music doesn't exist without performance.
Okay, but let me do my devil's advocate, play the old fogey here on you a bit. Okay. You know, when you're listening to Sinatra, all of his life, how he came up hardscrabble in New Jersey, and the pain, and Ava Gardner, and the whole 9 yards. That's all in every song that he sings. You know that's a part of it, and that's part of what attracts you to that music. If a computer just invented those songs and spit them out there, how can the relationship to the music, and how can it be the same?
Wow. Well, I think there's a Frank Sinatra hologram now. If we want to discuss the hologram
that might be
sort of
fantastic
situation,
or sacrilegious. I can't
it's
tell.
one or the other. People feel completely one way or another. Whether they love it or they hate it, there's completely no middle ground. So I think that people are very open to different genres, to different styles of music, to their friends' tastes, and I think you should listen to
You think I should?
Stuff.
Okay. All right, let me get a second opinion from Adam here. How far off do you think we are from the time when we're going to have an algorithm to create a personalized soundtrack for the book that you are currently reading?
Soundtrack. Well, I mean, this is not my area of expertise, but because,
Well,
literature...
the book part is.
The book part is, sure. In the video game world, there's a lot of work on music. Can you have, adaptive music that responds to the mood? So if there is the music technology, and music's very mathematical, so I would say, I think of art, music, literature, I think literature is going to be the hardest one to generate, but we can analyze it pretty well. So if we can see if it's a happy moment or a sad moment, or if the pace is picking up, there's a lot of dialogue, then if the music technology is there, then I think you could say, pick the pace of the music up, and you could attach them together. But I think in the actual creation of the narrative, it's very unlikely. But these kinds of multimedia things are really interesting. I was trying to think, is there right now an area of AI that can really add something to a narrative? And I struggle to think so in terms of literature, but in something like video games, I can imagine there's really great stuff for building worlds in video games, for instance. Like you want to make a fully sustaining ecosystem, and it would take a human a long time to actually draw out a whole world or a whole universe, and AI can do that really well. But for books, I don't think we need that. The human mind is still better, probably, at imagining.
That would be kind of a, as much as I think I object to the notion of a fake Frank Sinatra singing, there is something kind of cool about the notion that as I'm reading a book about whatever, there is, push a button on the side of the book and there's a soundtrack that just starts playing, I don't know what, some music while you're reading. That sounds kind of interesting, actually.
I think this is a point we're all coming back to. Like, art only, it's exciting to you to have this music that would play. And this is the thing, it's only if it means something to us. Like the computationally generated work of art is only good if it means something to us. So we decide. There are areas of the world where AI is going to solve some objectively useful task. Like this morning I'm reading about bricklayers, this is in the New York Times, bricklayers versus, human bricklayers versus robots. Well, like it makes sense to have an AI-trained robot to build a brick wall because it saves money. It only makes sense to have AI helping us generate music or narrative or images if we enjoy it, because it's for us. It responds to very human needs.
Okay, which jobs, David, let me go to you first on this one. Which jobs out there right now do you think are most at risk with the rise of automation, artificial intelligence, algorithms, et cetera? Which jobs currently in the arts-related field?
In the arts-related field, a lot of work where you're mostly doing a technical process. I mean, we're already putting parts of ourselves out of business in the sense of there's certain processes I don't bother to do anymore because I can get the computer to do it for me. I tend to work alone, so I'm just putting parts of myself out of business. But if you're in a group, then you're putting, for example, 3D printing and computational artificial intelligence optimization of engineering form. You can design really kind of bizarre structures that are incredibly light and very strong that you would never imagine designing. Well, that's replaced an engineer, a designer. There's someone involved in there. That's the person who's not going to be pushed off is the person who keeps trying to step beyond whatever is out there right now. And I think that's a kind of key thing. The way we get artificial intelligences to do these things is we feed them lots of data from the past. So we feed them every book that's available in an ebook fashion, or we look at these archives of paintings that are in all these archives around, available online. That's the past. For example, the piece we were talking about that created these artworks that people found as compelling as ones by humans, there are no works there that are really post abstract expressionism, which really hit its peak in the 50s. So there's always we're always potentially going to be out there out innovating the machines.
Let me ask Leanne whether she finds anything that we're discussing here somewhat disturbing. What's your view on that?
Well, I'd like to actually try to answer the question that you just asked, because I think it's a really interesting question. It goes back to the question of what creativity is. So taking the inverse of that question, what jobs would not be at risk of being taken over? And I think you have to ask the question, what is an artist or what is a creator? And a creator is someone who is right at the edge of taking parts of human experience and expressing them. And so I think those people who are right at the edge, taking parts of human experience that have not been put into words before, never been expressed before, those jobs are least likely. Any time that you have actually taken some kind of human experience, some kind of way of feeling or being in the world and turned that into turned it into a piece of music, at that point, you can imitate it with a computer. You can just look at how they've done that, how they've created it, and imitate it. But before that, you can't. And then that goes back to what is creativity? And people generally define creativity in terms of what is new and what is useful. But you can also define creativity in terms of the internal change or internal transformation that takes place in the creator's mind when they're creating. And if you define it like that, in that interior way, then the thing they're putting out into the world, music or the art, is almost just like the excrement of this creative process. It's almost just a way of keeping track of the change that's going on inside your mind as you're in the process of creating. And so someone who's right on the frontier of turning ideas and feelings into creative works of art, their job is not going to be taken over by a computer, because it's not until that's been done that you can find algorithms that can capture that kind of.
All right. Having said that, Catherine, if you're a copywriter, if you're a songwriter, if you're a music producer, if you're an editor, are you feeling a little vulnerable these days?
Some people are, but as everyone else has said, if it's those who are really wanting to do new and creative things, and everyone should be wanting to do new and creative things, are not in a position, this is going to be a new tool for them. But for people who catalog music, who have to try to keep track of all the data, this is just a wonderful, because no one's doing that. You can't do it. The volume is too big that humans can't do it. So that's a real boon in that business.
How do you see this changing the nature of the relationship between the artist and or writer and his or her work?
I don't think it necessarily needs to change it tremendously. I think it can give a boost, or a word I love using is defamiliarize. The computer can recombine things in a way that you wouldn't have expected. So one of the names I'm trying to use a lot when I talk about this project is this kind of forgotten Canadian artist, forgotten maybe in the mainstream, named Brian Gysin, who in 1960 used, I believe, the first generative process to make a poem using a computer. He was associated with the Beats. He, by some accounts, invented the famous cut-up method that Burroughs used. And he was living in the Beat Hotel in Paris in the late 50s with a programmer named Ian Somerville. And the two of them collaborated on a very simple program where you put a phrase in and it rearranges all of the words. So one of the things that I think that's fun about what's happening in the humanities right now, and we would say, by the way, all the jobs that are at risk are all of those jobs that do not happen in the humanities. And all the things that we do, judgment, creativity, we're going to do great. So all the enrollments for humanities are going to go up. But he read a program, or the two of them collaborated on a program that was not about solving a problem, but just about rearranging things in a new or interesting way. So put in a phrase, the famous one is, "I am that I am," and it would take those words and rearrange them and make all these really cool new phrases. So that's an example of what computers can do. It can just take, maybe you're stuck, you're looking for some kind of new combination of words, ideas, and it gets you started. The same way that the cut-up method or throwing a bunch of words into a hat becomes like a lyrics generator.
Do you have any concerns about what it's doing to your career or your ability to create?
It's taking a lot of time. The pace of change, I'm trying to keep up with what's happening in artificial intelligence right now, and the rate of research being published right out there. You get the code online, you can try it out. It's very hard to sit down and think about doing work because it's coming very quickly. So that's one concern. The other concern is it's not really about my work. I find it fascinating that I can make a program do things that I can't even do myself, that I can't even predict, even though I've done pieces where I've written all the code and I cannot predict what's going to come out, but what comes out is coherent, and that is, on one level, very exciting, stepping outside of myself or beyond the limits of who I am. And I think that's a little bit what you were just talking about, in the sense of that, the possibility that the tools can also take us beyond who we are as human beings.
That's a great place to finish up, because Leanne, I got 1 minute left here, and let me give it to you, because I wonder whether or not you think computational creativity could someday surpass human creativity.
It could surpass it in some senses, but not in others. So, similar to what the other speakers have been saying, there are things that computers are really, really good at doing, and in that sense, they've already surpassed us. But there are things that I don't think they would be able to do, at least not until they have some of the characteristics of a human mind. So a human mind is self-organizing, it's self-mending, it's a structure that is constantly rearranging itself and transforming itself. And until we have these kind of almost organic computers that have these self-organizing, self-mending qualities, I don't think they'll ever get anywhere near us in some respects.
Okay. After this program's over, I'm just going to check all of you to make sure I'm surrounded by actual humans here today rather than computers, just to be sure. Leanne Gabora from the University of British Columbia, thanks so much for being there via Skype on the left coast for us. We've really appreciated your time tonight here on TVO. Catherine Moore from the University of Toronto. Adam Hammond from the University of Toronto, David Rokeby, digital media artist. Great to have all of you on TVO tonight. Thank you so much.
Thanks.
The Agenda with Steve Paikin is brought to you by the Chartered Professional Accountants of Ontario, helping businesses stay on the right side of change with strategic thinking, insightful decisions, and business leadership. Are you on the right side of change? Ask an Ontario CPA.